All right. There we go. Here we go. We have 2 lessons left in this chapter. We have a test coming up on Friday. This is section 1.10, which is the real number system. And we want to be able to understand the different subsets of numbers, the different smaller sets of numbers that are within the real numbers, our number system that we know and love. You don't need your computers up right now, so would you please lower those screens down to convince me that you're not doing something you shouldn't be. Thank you very much. Lower those screens. Gracias. Okay. All right. So you can see down here we have a nice little picture we're going to complete. This is our real number system and how we can organize it in a really nice way. So we're going to fill that out. I'm excited. I love that. So the real numbers are the set of all numbers which contain all rational and they contain all rational and irrational numbers. So we have a bunch of numbers, and you guys have been playing around with all the different kinds of numbers in this whole unit. So we've been building upon our number set. And so the real numbers are basically broken down into rational numbers and irrational numbers. And that's what this set represents down here. So this whole box right here represents the real numbers. And these real numbers get split up into 2 different groups. Over here, this little baby egg right here, these are the irrational numbers. Irrational numbers. I'm going to use this symbol. That's the symbol for numbers. I know you might know it as a hashtag, but it's really the number symbol. We've been using it for years and years and years. And then one generation appropriated it as a hashtag and ruined math. No, just kidding. All right, so these are the irrational numbers. And then in this big giant blob right here, these are the rational numbers. All right, so we have basically 2 big groups of numbers, irrational and rational. So let's talk about those 2 sets here. So back at the top. Irrational. I love talking about language. Irrational. Well, let me talk about rational first. Rational. I love saying rational fractional. Rational fractional numbers are numbers that we can write as fractions. So all fractions or numbers that can be written as a fraction, like a over b, where a and b are integers. So for instance, 8 is a rational number. Is it as a fraction? Can I write it as a fraction? Yeah, I certainly can. I can write it as a over 1. So it's called a rational number because I can write it as a fraction. I can also represent 8 as 16 over 2. What is 16 over 2? 8 as well, okay? And in fact, I could go all day. I could do 32 over 4. That is also how I could write 8 as a fraction. So I can take any number and I can write it as a fraction. And so any integer also happens to be a rational number. It turns out that decimals that terminate can be written as a fraction. What does it mean to terminate? The Terminator. Destroy. Yeah. It means to stop, to put an end to, okay? So decimals that terminate, decimals that stop, are decimals that we can write as a fraction. So for instance, 0.25. That is an example of a decimal that stops. It doesn't go on forever, okay? Ladies and gentlemen, 0.25 can be written as a fraction. 25 hundredths, right? That's why we call it 25 hundredths, because we can write it as a fraction, 25 over 100. We did this. It also reduces to 1/4. So 0.25 is a rational fractional number because I can write it as a fraction, okay? What about 0.375? Is this a rational fractional number? Yeah. Why? Because it can be written as a fraction. What's my fraction here? 375 thousandths. Very good, ladies and gentlemen. So if you have a decimal that terminates, we can always write it as a fraction. Now, decimals that have a repeating pattern, I don't know if I want to say that. That's a weird way to say that. Well, that's okay. Decimals that repeat can also be written as fractions. So for instance, let's see, repeating patterns. So maybe something like 0.33333 that goes on forever. What's these little dots mean? A lot. Goes on forever. All right. 0.333. Do you know what fraction 0.3333333 is? No? Well, let's see. Just in case you're curious, this would be 0.3 repeating. And 0.3 repeating with the little repeat bar, anything that has a repeat, we can write, Seamus, put your feet down. We can write with a fraction with a 9 on the bottom. So this just becomes 3 over 9. Watch what happens when I test this in my calculator. 3 over 9, 0.333333333. Okay, pretty interesting. If I had a fraction, or not a fraction, a decimal that went 4545 ... Is it a repeating decimal? What's repeating? 45, yeah, so 0.45 repeats. Again, I can write that as a fraction, just putting 9s underneath it. So 45, and now because there's 2 digits, I need 2 9s. 45 over 99, watch, 45 over 99. Crazy! Look at that, 0.454545, pretty cool, okay? So if you have a decimal that repeats, then we can write it as a fraction. So rational numbers are anything that we can write as a fraction. We have lots of examples here. I hope you wrote them down. Okay. So let's go to irrational. Rational numbers, I like to say rational fractional because that helps us remember, right? Rational means we can write it as a fraction. Rational fractional. Make sense? Okay. So irrational. What do you suppose ir means when we have a word like irresponsible? Not. Very good. That is exactly what that means. Ir means not rational. So now that you know ir means not, what are irrational numbers? Not fractions. We cannot write them as fractions. So these are decimals that cannot be written as fractions. That is very important. irrational numbers cannot be written as fractions. And so what's really, really nice is to think about, like, irrational people. I am a very rational person. What's an irrational person? Finley, what do you think? Okay, spends a lot, kind of crazy. Maybe they're just kind of crazy people. I am very orderly, organized. All right, that's me. I'm totally logical, straightforward. Irrational, I like to think of them as crazy people, okay? Totally crazy. Irrational things are decimals that are totally crazy. They never terminate and never repeat. They are crazy, crazy decimals. Okay? They are crazy balls. All right? Like, for instance, pi. Do you guys know that you have a button here on your calculator called pi? You see it's blue? And so if we do second pi, you can see pi, 3.14159, blah, 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 blah. Okay? Would you call this a lovely rational decimal or a totally crazy decimal? It's a crazy decimal, okay? So pi is an example of an irrational number. It's totally crazy, all right? Also, if you were to try the square root, oops, sorry, that's not square root, the square root of, say, 17. Look at that decimal. Is it a nice, neat decimal, or is it a crazy decimal? It's crazy, right? So the square root of 17 is a decimal that goes on forever, 4.123, da, 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 da. It does not repeat. It's totally patternless. It's crazy, all right? So that's how I like to think about numbers. Is it a crazy number, or is it kind of okay, all right? Does it have a pattern? Does it have some logic to it, okay? All right. So we have a couple other subsets of numbers here that I want to talk about a little bit. So within our lovely rational numbers, we have a few other subsets. We've been talking about integers. What are integers? This is like day one lesson. Negative number, yeah. So these are the positive and negative whole numbers. So for instance, we started at 0, and if we move to the right, we have 1, 2, and 3, and so on and so forth. And if we move to the left, what else do we have? We have -1, -2, and -3, and so on and so forth. So integers are the positive and negative numbers. Whole numbers is a little smaller than this set. The integers does not include any numbers in between, okay? Just the nice, pretty, beautiful integers, just the nice values. Whole numbers, I like to think about this word whole right here. It gives you the answer. Whole numbers have a 0 and a 1. It starts with 0, 1, 2, 3, and so on and so forth. So the whole numbers, do you see the 0 inside the word whole? Got to pretend a little bit, but that's how you remember the whole number starts with 0, and then it goes to 1. So 0, 1, 2, 3. It's about half the size of our integers, so it's a little smaller. And the natural numbers, this is how babies learn to count. When you were a baby and you stacked blocks, and you'd go, what did you start with? 1, and then 2. So these are the natural counting numbers where we're starting with 1, okay? So this is the smallest set. So this small bubble down here, this represents the natural numbers. The natural numbers, everything in here. So that'd be like 1 and 2 and 3 and so on and so forth. What's slightly bigger than the natural numbers? The whole numbers. So this is second. The whole numbers. Slightly bigger. What's bigger? What makes it a little bigger? The zero, yeah. 0, 1, 2, 3, and so on and so forth. And again, these are just nice, beautiful numbers. And then what's slightly bigger than the whole numbers? Integers. I-N-T-E-G-E-R-S. The integers, what are the integers? Negative and positive. So -3, -2, -1, 0, 1, 2, and 3. So that includes the positive and negative whole numbers. The rational numbers include all of the things inside it already, but now we also get to include things like 2/3 and 4/8 and give me a fraction. 1836. Love it. -1836. That's in there. 2/5. -4/3. So all of these lovely things that we can write as fractions. All right. And also 2/1. All right. -2/1. All right. Because those are already in there. They're right there. There's 2/1. All right. Irrational numbers. What are some irrational numbers? Pi is a good one. What's another one? Radical 3. Yeah. What about, I have a question. Where does the square root of 4 go? Rational, yeah. The square root of 4 is 2, so it actually is a rational number. It's actually just an integer. So it could be, it's a natural number. Works out nice. You know what I mean? Okay. All right. So let's talk some more here. Let's turn the page. All right, we want to name all the sets to which each number belongs. -47. It is definitely an integer. And if it's an integer, what also is it? Rational. Very good. So we know it's an integer because it's got negatives, and we know it's a rational fractional number. Good. Number 2, what does that belong to? Rational. Rational fractional. It is a rational number. It's a mixed number. It includes a fractional part, so it's got to be part of the rationals. This can clean up. What is the absolute value of -9? Just 9. Tell me about 9. Natural. It is a natural counting number. What else is it? If it's natural, what else is it? Yeah, if it's a natural number, it's also whole and integer and rational. It's in all of these. So it's natural, whole, integer, and rational. So if it's in that smallest subset, it's a part of everything. Radical 23. Hey, let's use our calculators for a second. Radical 23. What do you think? Is this going to be a nice decimal or crazy? Crazy. Crazy. It is a crazy decimal. 4.79583 dot, 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 dot. It's crazy. If it's crazy, what set is it part of? Irrational. Very good. IRRATIONAL. Okay. Irrational. It's a crazy number. All right. Tell me about 5. Look at that decimal. Would you call that crazy or nice and tidy? Does it go on forever? No. So it's not too bad, actually. All right. This is a terminating decimal. It stops. It's long, but it does stop. And because it terminates, what part of the system are we in here? Rational, yeah. I can write this as a fraction. It's 1 plus 5, 6, 2, 5 over 1. Dude, 1, 2, 3, 4 zeros. Over 10,000. So I can write it as a fraction. This is rational fractional. I can write it as a fraction, so it's rational fractional. 0! 0 is a special number. What sets is 0 a part of? Not all of them. Is it part of the natural set?
Yeah.
Whole. Remember, whole starts with 0, 1, and so on and so forth. It's got the O and the L in there, which I can pretend is a 0 and a 1. So 0's first appearance is in the whole numbers. So whole, integer, and rational. All right, what about negative root 64? I think that simplifies. What is the square root of 64? 8. With a negative becomes negative 8. All right, where does negative 8 belong? Integer. And if it's part of the integers, it's also rational. All right. And what's this bar mean? Repeating. And if it's a repeating decimal, what is that? Rational. No, rational. Repeating. Repeating, it's got a pattern. It's lovely. It's got a lovely repeating pattern. So that can actually be a rational fractional number. And I could write that as 123 over 999 with a negative out in front. We can write it as a fraction, which is kind of cool. I mean, you can test it. 123 over 999. Look at that. 1, 2, 3, 1, 2, 3, 1, 2, 3. Really neat little pattern going on there. Okay? Really cool. Negative 24 over 6, that cleans up. What does it clean up to? Negative 4, very good. Negative 4 is part of which groups? Yeah, it's definitely an integer and rational. Great. And cube root of 8. I think cube root of 8 cleans up. Where can we find the cube root button in our calculator? Math. Under the math menu, we got the cube root of 8. What do you think it is? 2, because 2 times 2 times 2 is that 8. So it is 2. That cleans up super nice. Where does 2 fall in our little system here? All of it, well, all of this side, yeah. Natural, whole, integer, rational. Natural, whole, integer, and rational. Can I just abbreviate NWIR? Is that okay with you? Makes it easier, right? Oh, I guess I'm going to do int for integer, so I don't confuse that with irrational. All right. Real fast here, we're going to write in where these numbers belong. She wants you to actually put the letter. I'd rather just put the numbers where they belong. So what kind of number is the negative root 50? Is it rational or irrational? And if you don't know, what can you do? Use your calculator? Yeah, so square root. The square root of 50. Look at that decimal. Oh, you can't see that. There you go. Look at that decimal. Is it totally a crazy decimal, or is it kind of a pretty decimal?
Crazy.
It's crazy, right? So crazy means irrational. So negative root 50 goes in the irrational. All right, what about 3.895? Is that an okay decimal?
Yeah.
It is. So it goes in the rational. 3.895. That's an okay decimal. It's not crazy. It's okay. It's okay. All right, where does 8 belong? Natural number. That's where it first appears in the natural numbers, right there. It's part of all of these. Where does negative 11 first appear? Integers, where it first appears since it's negative. All right. Negative 4 1/5, where is that going to go? Rational fractional. Very good. Rational fractional. Where's pi? Irrational. Why? It goes on forever. It does not terminate. It's crazy. Crazy decimal. Okay. What about G? 1.7 repeat. Rational fractional. Hey, 1.7 with a repeat. That repeating is kind of nice. It's kind of cool. All right, so that's a fine. Ooh, I don't know about the square root of 196. What should I do? Calculator. So square root of 196 turns out to be 14. So where should that go? Natural numbers. That's where it first is going to appear because it equals 14. So the square root of 196 is 14. So it's a natural number. What's the square root of 0? Yeah, that's interesting. Where does that first appear? Whole numbers. Very good. Remember, whole starts with 0 and then 1 and goes on and on. So the square root of 0 equals 0. I think. I want to double check. Make sure there's not some rule I'm missing. Yep, square root of 0 is certainly 0. J cleans up. What does that clean up to? Yeah, the absolute value of negative 34 is 34, and it's got a floating negative out in front. So it's negative 34. Where should that belong? Integers. Negative absolute value of negative 34 really just cleans up to negative 34. So it belongs as an integer. Ooh, interesting. 3 to the negative 1. What do negative exponents do? They're sad. They're sad exponents. Where do they want to go? Bentley, what do you think? You turn it into a fraction. Yeah, 3 to the negative 1 is 1 over 3 to the now happy 1, right? So this was happy sad math. This takes us back, right? So now this is a nice little fraction, 1/3. Where does that belong? Rational fractional. So 3 to the negative 1 really is 1/3. This is like a great review here. What is 27 over 9? It is just 3. Where does that belong first? Natural numbers. 27 over 9 is really 3. That's where it first appears. It means it's in all of those bigger than it. What is this? 7 times 10 to the negative 2. Sad. It is sad. This is scientific notation. Now, what kind of number? If our exponent is negative, is that going to give me a big number or a little number? It's a little decimal here. So if you remember, we have our decimal point at the 7. It says, hey, move us left 2 spaces, so we get 0.07. All right. So that's that decimal, 0.07. Is that a okay decimal or a crazy decimal? It's okay, yeah. So 7 times 10 to the negative 2 is a rational fractional number. And we know the square root of 4 is 2. So with a negative, that cleans up. Where does it belong? Integer. Very good. Negative square root of 4 right there. It's really just a 2. All right, ladies and gentlemen, what's the difference between rational and irrational? Rational fractional. You can write it as a fraction. Tell me about the decimals. They're not crazy. All right. Could they go on forever? Technically, they can if they are repeating. All right, if they got a nice repeating thing going on, then those are okay. Irrational, tell me about irrational numbers. Crazy, totally crazy decimals. There's no pattern. They are completely crazy, irrational, all right? So you have a Delta Math today. I also have a paper assignment if you want to do that. You can do that for extra credit, okay? So let me know. Otherwise, you're working on adults math. It should be pretty easy. Okay.